Let's talk about what just happened. Because if you are paying attention to the flow of scientific data regarding the interstellar object 3I Atlas, the last 48 hours have been nothing short of a paradigm shift. And honestly, a massive frustration for those of us in the Western scientific community who are used to a certain level of transparency. We have a situation where the China National Space Administration, the CNSA, has just dropped a dataset that is effectively rewriting the book on this object. While NASA, my own agency's partners, the people I have looked to for leadership in orbital observation for my entire career, is maintaining a radio silence that is becoming impossible to justify. I want to walk you through exactly what we are looking at in these new images from the Tianwen-1 orbiter. Contrast it with the absolute void of high-resolution data coming from our own assets like the Mars Reconnaissance Orbiter, and explain why the physics of this object is starting to make the "just a comet" narrative look incredibly shaky. The headline here is the release of high-resolution imagery from China's Tianwen-1 Mars orbiter. Let's be clear about the technical achievement here. Capturing a fast-moving interstellar object from a planetary orbiter is not a point-and-shoot operation. You are dealing with an object moving at hyperbolic excess velocities, meaning it is not bound to the sun, traveling at speeds that dwarf anything native to our system relative to a spacecraft that is itself orbiting Mars at thousands of kilometers per hour. The targeting algorithms required to slew the high-resolution imaging camera, or HiRIC, to lock onto a target like 3I Atlas are complex. We knew China was attempting this. What we didn't expect was the fidelity of the data they would release. The images released by Beijing are not the fuzzy, pixelated smudges we usually get from ground-based telescopes or even the initial raw dumps from deep space probes. These are resolved images. We are seeing a defined nucleus. We are seeing a coma structure that is asymmetrical, which is the first massive red flag that the standard outgassing models are incomplete. In the Tianwen-1 data, there is a clear, distinct jet structure. Not a chaotic sublimation where ice just boils off into space because of solar heating, but collimated streams of material. Specifically, the Chinese analysis points to 3 distinct jets on the sunward side, and, crucially, a 4th jet firing away from the sunday. That anti-solar jet is the detail that keeps me up at night. In standard cometary physics, you expect activity primarily on the side facing the heat source. To have a sustained, energetic release of material on the dark side of the nucleus implies either a significant thermal lag, meaning the heat is being retained and rotated around, or an internal mechanism that we do not currently understand. And this brings me to the color data. The breakdown of the spectral data released alongside these images confirms what independent observers have been screaming about for weeks. The object is blue, not the pale, dusty white blue of a standard comet reflecting sunlight, but a deep, spectral blue that suggests an abundance of ionized gas, specifically dominated by emission lines that don't match the typical water ice or carbon monoxide ratios we see in Oort cloud comets. When 3I Atlas passed perihelion, that blue intensity didn't just scale linearly with solar proximity, it spiked. The Tianwen-1 data shows that this blue shell is distinct from the dust tail. It's almost like a shroud. If this were a simple, dirty snowball sublimating, the dust which reflects the full solar spectrum should wash out that color. It isn't. The gas emission is overpowering the dust signal, which implies a composition that is incredibly volatile or, dare I say it, artificial in its purity. Now, look at the other side of the aisle. While I am sitting here analyzing JPEGs released by the CNSA, I am refreshing the NASA Planetary Data System, and I am seeing nothing. This is not normal. We know for a fact that the Mars Reconnaissance Orbiter, the MRO, had a better viewing angle than Tianwen-1. The high-rise camera on MRO is largely a superior instrument to HiRIC in terms of raw resolving power. We know the observation sequences were uploaded. We know the data was downlinked. The Deep Space Network logs show the packets coming in. And yet, weeks after the encounter, we have silence. The processed images released are low-resolution, point source dots that look like they could have been taken by a backyard telescope in the 1990 seconds. Why is NASA withholding the high-rise data? I don't want to speculate on conspiracy theories, but as a scientist, I have to look at the variables. If the MRO data showed a standard comet, it would be on the front page of the NASA website with a press release about planetary defense and international cooperation. The fact that it is buried suggests that the MRO data corroborates the anomalies seen in the Chinese data, or perhaps shows something even more difficult to explain. We are talking about an agency that live streams Mars landings. The decision to go dark on the most significant interstellar intercept in history is a decision that comes from the top, and it suggests fear. Fear of misinterpretation, perhaps, or fear that the data contradicts the natural object consensus that was established before we even really looked at this thing. Let's dig into the trajectory, because this is where the boring comet hypothesis falls apart mathematically. The new astrometry from the Tianwen-1 encounter, combined with the ground-based observations from the last month, has allowed us to refine the orbital solution. 3I Atlas is exhibiting non-gravitational acceleration. Now, comets do this. It's called the rocket effect. Gas shoots out one way, the comet gets a kick the other way. We saw it with Oumuamua, and it was the primary argument for its artificial nature then too. But with 3I Atlas, the values are wrong. The acceleration component, what we call A1, is fluctuating. In a natural comet, the non-gravitational acceleration should be smooth. As the comet gets closer to the Sun, it heats up, outgassing increases, and the acceleration ramps up. As it moves away, it cools down, and the acceleration drops. It's a curve. 3I Atlas is not following a smooth curve. We are seeing stepped changes in acceleration. It's almost impulse-based. It accelerates, then coasts, then accelerates again. The Chinese data helps us correlate these kicks with the jet activity, but the force vector doesn't always align with the visual jets. That is physically impossible if the jets are the cause of the acceleration. You cannot have a jet firing retrograde and the object accelerating prograde. That violates Newton's third law. Unless, of course, the visible jets are not the primary propulsion mechanism, or we are misinterpreting what those jets actually are. The trajectory analysis has another disturbing coincidence. This object is on a hyperbolic path, meaning it's leaving the solar system, but on its way out, its node crossing with the ecliptic, the plane where all the planets orbit, is suspiciously precise. It passed near Mars. It's going to pass near Earth's orbital distance, and the future track takes it into a proximity with Jupiter that is dynamically interesting. Some of my colleagues have pointed out that the perigove, the closest approach to Jupiter, matches the planet's Hill sphere radius almost exactly. The Hill sphere is the region where a planet's gravity dominates over the Sunday. Entering that region is how you execute a gravitational maneuver. For a random rock drifting through the galaxy for billions of years, to thread the needle of our inner solar system and kiss the edge of Jupiter's gravitational influence is a statistical long shot. Not impossible, but unlikely enough that you have to ask questions. The silence from NASA becomes even more deafening when you realize that we have assets specifically designed to look at this. The James Webb Space Telescope. We know JWST took spectra. We saw the scheduling logs. The near-infrared spectrograph, NIRSpec, is the perfect instrument to tell us exactly what those jets are made of. If it's water, 2,2, and methane, tell us. If it's complex hydrocarbons or something exotic, tell us. The fact that the JWST spectra haven't been published in a preliminary paper is baffling. Usually, with a target of opportunity this hot, you have a Nature or Science paper submitted within days. Here, the principal investigators are tight-lipped. I've reached out to colleagues at the Space Telescope Science Institute, and I get pending processing or calibration issues. You don't have calibration issues for 2 months on a flagship mission unless the data is weird. Really weird. Let's go back to the Tianwen-1 images. I mentioned the coma diameter. The Chinese press release states it is several thousand kilometers across. That's huge for a nucleus estimated to be only a few kilometers wide. But the density of the coma is low. It's tenuous. This contradicts the visual brightness. To have something that bright but that diffuse means the particles are highly reflective. We call this high albedo. A standard comet is dark. Cometary nuclei are usually darker than coal, reflecting about 4% of the light. The dust they emit is also dark. 3I Atlas seems to be shedding material that is incredibly shiny. Metallic dust? Ice crystals with a specific lattice structure that creates specular reflection? The blue anomaly I mentioned earlier ties into this. In the new photos, there is a gradient. The core is bright white blue, fading to a deep indigo at the edges of the coma. This is characteristic of fluorescence. We see this in comets with high levels of carbon monoxide, CO+, which glows blue. But to get that intensity, you need a lot of CO. And if you have that much CO, the volatility is off the charts. The object should be breaking apart. We've seen comets disintegrate when they get this active. Comet Atlas, the other one, C2019Y4, fragmented. 3I Atlas is staying solid. It's taking the heat, it's pumping out gas, it's accelerating, but the nucleus is structurally sound. This implies a tensile strength that is higher than a rubble pile. It suggests a monolithic object. I want to pivot to the drill that is happening right now. You might have seen the headlines about the UN-backed planetary defense campaign. The International Asteroid Warning Network, IAWN, has turned 3I Atlas into a live target for a communication and tracking exercise. On paper, this makes sense. It's a fast mover, it's passing relatively close, it's a good test of the system. But the timing is suspicious. You don't usually initiate a high-level global defense drill for an object that is confirmed to be on a safe trajectory unless you want to test the coordination protocols for a threat. It feels like a cover to mobilize every telescope on the planet to track this thing without causing panic. By calling it a drill, you explain why deep space radars and government assets are all pointing at it. But you don't have to explain why you are so worried. And, make no mistake, the worry is real. I'm seeing chatter on the closed listservs. The orbital refinement from the Mars data, the data China released, and the data ESA, European Space Agency, triangulated tightened the error bars on the trajectory by a factor of 10. That's good science. But it also revealed that the non-gravitational parameter is not constant. It's evolving. If the object decides to burp again, or if that anti-solar jet kicks into high gear, the trajectory changes. We are confident it won't hit Earth. The missed distance is 170 million miles, roughly. That's safe, but the unpredictability is the problem. You cannot predict the path of an object that has an engine, or acts like it has one. I use the word engine provocatively, but we have to be rigorous. In 2017, Oumuamua tumbled. It was a cigar shape, tumbling end over end. That is a natural state for a collision fragment. 3I Atlas is not tumbling. The light curve data suggests it is stable. It has a rotation period, but it's a principal axis rotation. It's keeping its orientation relative to the stars, or perhaps relative to its velocity vector. The Tianwen-1 images show the jets are fixed on the surface. If the object was tumbling chaotically, the jets would spray in a spiral. They aren't. They are directional. That implies a stabilized platform. Whether that stability is gyroscopic or aerodynamic, which doesn't make sense in a vacuum, or active, it's another data point that separates this from the average rock. Let's talk about the anti-tail. In the amateur images and verified by the Chinese release, there is a spike of material pointing towards the sunday. An anti-tail is usually an optical illusion caused by the geometry of the Earth crossing the comet's orbital plane, where we see heavy dust particles left behind in the orbit. But the geometry right now doesn't support a geometric anti-tail of this magnitude. This looks like a physical outflow. A jet firing forward. In orbital mechanics, if you fire a thruster towards the Sun, retrograde, you slow down, which drops your orbit. If you fire away from the Sun, you speed up. 3I Atlas is doing things that seem dynamically contradictory unless you model it as a complex body with multiple active regions triggering at different thermal thresholds. But why the silence? Why would NASA sit on this? Let's assume the most benign explanation. The data is confusing. Science is messy. Maybe the high-rise images are full of artifacts. Maybe the JWST spectra are so saturated that they need months of calibration. That is possible. But in the current media environment, silence is interpreted as concealment. By not releasing the raw data even with a preliminary, uncalibrated stamp on it, NASA is ceding the narrative to China. The CNSA looks like the transparent scientific leader here. They saw the object. They took the picture. They shared the picture. NASA looks like the old guard protecting a secret. This has happened before with the face on Mars or the Tic Tac UFO videos. When the government hoards data, the public fills the void with speculation. But this time, the speculation is coming from inside the house. It's coming from astronomers who are looking at the A1 parameters and saying, this doesn't fit the curve. It's coming from spectroscopists saying, that blue line isn't CN or C2. The upcoming Earth close approach in December is the final exam. As 3I Atlas moves away from the Sun, it is now in the outbound leg. This is usually when comets quiet down. They cool off, the jets shut down, they fade. If 3I Atlas stays active, or worse, if it brightens again as it passes Earth, then the natural comet hypothesis is dead. A natural object cannot generate energy without an external heat source. If it stays bright while moving away from the sun, it has an internal energy source. That could be radioactive decay, unlikely to be this bright, a chemical reaction, or something artificial. The Chinese data hints at this. They reported that the brightness temperature of the nucleus is higher than the equilibrium temperature for a body at that distance. It's running hot. Why? Is it porous and retaining heat, or is it generating it? The verified information I can give you is that the thermal inertia values derived from the Tianwen-1 IR instruments are anomalous. They don't match the thermal inertia of a rock or a snowball. They match something with a high thermal conductivity, like metal, or something with active heat dissipation. I want to circle back to the interstellar nature of this. We know it came from the direction of Sagittarius. It's likely from the thick disk of the Milky Way, meaning it's old. Stars in the thick disk are 10 billion years old. This object has been traveling for eons. The fact that it still has volatiles to burn, that it still has ice to turn into jets, is surprising. After a billion years in the cosmic ray environment of interstellar space, the surface should be cooked into a dark, organic crust. This is what we see on Kuiper Belt objects. We call it space weathering. 3I Atlas looks fresh. The blue color, the high albedo, it looks like it was minted yesterday. How does an object travel for 10 billion years and arrive looking brand new? One hypothesis is that it's a fragment of a larger body that was recently shattered, a fresh shard of ice from a destroyed planet. That would explain the fresh surface, but it doesn't explain the stability or the weird acceleration. Another hypothesis, the one no one wants to put in a peer-reviewed paper but everyone talks about at the bar after the conference, is that it's not a natural object. It's a probe, and it's waking up because it entered a solar system. I am not saying it's aliens. I am saying that as a scientist, I look for the hypothesis that fits the data. Right now, the dirty snowball hypothesis requires so many caveats. It's a snowball, but with exotic chemistry and unusual structural integrity and weird thermal properties and coincidence trajectory that it's becoming Occam's razor in reverse. It's getting too complicated to be the simple answer. The comparison with 2I Borisov, the second interstellar object, is instructive. Borisov looked like a comet. It acted like a comet. It had a tail, it had a coma, the chemistry was recognizable. NASA was all over it. We had data flowing like water. Why? Because it was safe. It was understandable. It fit the model. 3I Atlas does not fit the model. And that, I suspect, is why the data flow has been throttled. What we need now is for the scientific community to demand the release of the MRO and JWST data. We cannot let geopolitical rivalry dictate the flow of scientific knowledge. If China has the best data, we use China's data. But we know the US has data. The planetary defense drill, the IAWN campaign, supposedly involves data sharing. So where is it? Why are the minor planet center circulars only showing astrometry position data and not photometry brightness color data or spectroscopy composition data from the major US observatories? There is a gap in the logs. If you look at the observation dates, there are periods where we know the object was visible, we know telescopes were active, but no data points are registered. These blackout periods coincide with the moments of highest activity, the kicks in acceleration. Did the object do something during those windows that was too anomalous to release without verification? The Tianwen-1 images are the first crack in the dam. They show the jets, they show the asymmetry, they show the blue halo, they validate the amateur astrophotographers who have been doing the heavy lifting while the billion-dollar agencies sit on their hands. It proves that the internet rumors about the blue spectrum and the jets were real. It validates the citizen science community. Going forward, watch the trajectory updates, not the press releases, the raw orbital elements. Watch the A1 parameter. If it keeps changing, if it stays high as the object moves away from the sun, we are dealing with a propelled object. Watch the color. If it stays blue as it gets further from the sun, it's not fluorescence, it's emission. And watch the silence. If NASA continues to say nothing while 3I Atlas makes its closest approach to Earth in December, that silence will tell us more than any press release ever could. We are living through a historic scientific event. The data is out there, it's just not being distributed. China has made their move. They have shown their hand. Now it's time for the rest of the world to open the files and let us see what 3I Atlas really is. Because right now, the most advanced sensor systems humanity has ever built are staring at this thing, and the people who paid for them, you and I, are being left in the dark. And that is not how science is supposed to work. We have a unique opportunity in the next few weeks. The object is bright enough for decent amateur equipment. If you have a telescope, look at it. Take spectra if you can. Document the jets. Because it seems that in 2025, the only way to get the truth is to go out and find it yourself. The official story is lagging behind reality. The Tianwen-1 photos are just the beginning. The real story is what happens next. And whether we will be told about it, or if we'll have to wait for another leak or another foreign space agency to do the job, that should be a global cooperative effort. I'll be monitoring the Minor Planet Center databases and the raw image servers from the DSN. If anything slips through, if any new spectra appear, I will analyze them immediately. But for now, take the Chinese data seriously. It's high quality, it's verified, and it shows an object that defies our standard models. 3I Atlas is not just a visitor, it's a puzzle, and it's one that we are running out of time to solve. The next few weeks are critical. The Earth flyby is the last good look we get before it heads out into the dark. Let's hope the shutters are open.